Hey class. All right, so this is our recording for 3 I believe, let's see, what is this one? Chain rule, so is that 3.6? 3.6, okay. So this is 3.6, example 5 and 6 in your notes packet. So repeated use of the chain rule. So let's, again, I'm going to start with what let u be, okay? Since I have an inner component, this is my inner component right here. Let u be that inner component. 1 plus cosine of 2x. Looks like if you can see this, I'm about to take the derivative of this, okay? So u prime is, and do this very cautiously. The derivative of 1 is 0 because 1 is a constant. The derivative of cosine is negative sine. Okay, so technically, this is the derivative of cosine of 2x, which if you really wanted to, you can let 2x be another variable. Let's just say w or v, okay? And then do another chain rule in that way. But I'm going to do this. So derivative of cosine of 2x is negative sine of 2x times, based on your chain rule, times the derivative of the inner component. So u prime is negative sine of 2x times the derivative of 2x is just simply now 2. Then let's put the 2 in the front. That u is extra long, isn't it? Let's put u in the front, not u, 2 in the front. So this is really negative 2 times sine of 2x. So that is the derivative of 1 plus cosine of 2x. So now what I need to do is not move the screen. What I need to do is rewrite this equation. As you can see, y equals, the inner component is now u and then square, okay? So it's going to be u, so y prime is going to be 2 times u prime. Now I just have to plug everything back in and make sure I foil or multiply everything out nicely. Well, u is simply 1 plus cosine of 2x. That came from this right here, okay, and that's in the component. Then u prime, that piece right here, u prime is what we had to do on our own. So times u prime, which is now negative 2 times sine of 2x, okay? Then let's try to multiply this out very slowly. You can technically multiply this and this first, so let's do that, okay? So 2 times that is now negative 4 sine of 2x, and then that is now 1 plus cosine of 2x, bring that down. So what I did was I multiply this and that first. Okay. So now let's slowly multiply this out. Here we go. Negative 4 sine of 2x times 1 is negative 4 sine of 2x. No big deal. Negative 4 times that right there is going to be minus 4 sine 2x cosine of 2x. Okay? So negative 4 sine 2x and cosine 2x is just, we can't do anything about it right now. So let's leave that as is. Now, I hope you remember the identity. This is from memory, okay, of double angle of sine and cosine. So let's do sine first, because this is what I see. Sine of 2 theta, remember back in the days, is going to be 2 cosine of theta times sine of theta. Well, what if you have sine of 4 theta? Sine of 4 theta is just simply 2 times that, right? Which is really sine of 4 theta. So what if you have sine of 4 theta? Then what that is really 2 cosine instead of just a theta. Now it's 2 theta. Okay, so 2 theta cosine of, oops, I already had cosine, so sine of 2 theta. Cosine of 2 theta and sine of 2 theta. So that is sine of 4 theta. Now, why do I need to know this? Well, I kind of see a couple of things in my answer here, right? I have this guy right here. You see this guy right here? I can rewrite that as, I'm going to copy this down, negative 4 sine of 2x, leave that as is. I'm going to rewrite 4 as a 2 times 2 sine of 2x cosine of 2x. Okay, this right here is a double angle identity of sine of 4x. So now I will definitely need to put it back in -2 times sine of 4x. Okay. So as you can see, this is a lot simpler to look at. So -4 sine of 2x minus 2 sine of 4x. I'm just trying to get rid of that dot right there. Now I can combine these. So guess what? This is as far as we will go. Okay. So final answer. So the derivative of 1 plus cosine 2x, all of that quantity square, is -4 sine of 2x minus 2 times sine of 4x. Now, let's do the last example in the chain rule section. Okay. Again, you have y equals square root of tangent 5x. I'm going to let the inner component be u. Okay, so u equals tangent of 5x. Then let's do u prime. U prime is tangent, the derivative of tangent is secant square of 5x, and I need to multiply based on the chain rule the derivative of the inner component, okay, which is 5x. Now, slowly copy this down, secant square of 5x. I don't need to do anything with that, but the derivative of 5x is just now 5. But I'm going to write that in the front so I'm not confused. That would 5x times 5, and that's 25x. That would be completely different from secant square of 5x. So the derivative of tangent 5x is 5 times secant square of 5x. So that's my inner component. So what do you need to do here? Write y equals square root of u. Okay. Now, if you wish, you can totally write square root of power of half. Okay. Move that over. So y prime, based on my power rule, is 1/2 times u. Subtract 1 from a half is now -1/2 times u prime. Then from here, slowly work this out. And no, you have multiple ways of doing derivative. You don't have to do it this way. So now I have positive 1/2. U is this guy. Okay, so plug that in. Is now tangent of 5x to the power of -1/2. U prime is u prime is now this guy, so plug that guy in. Okay, so u prime is 5 times secant square of 5x. Now let's try to make it as pretty as we can. Not all the time that you're going to be able to make it really pretty, but we will definitely try our best. Okay, tangent 5x to the -1/2 power, class, is the same as 1 over square root of tangent 5x. Okay, and again, that is true. Well, if that's too fast for you, how about this? I'll write it in this way first. Tangent 5x to the positive power of half, and bring it to the bottom. Because anytime you have a negative exponent, you can move it to the bottom to make it positive. Then I'm going to make this into a fraction as well. What I'm trying to do is I'm going to write everything out in multiple steps so you can see how we go from one to the next. So y prime is, now I can write it in radical, so here we go, square root of tangent of 5x, okay, times 5, so, well, 5 secant square of 5x times 1, that's just now 5 on the top, so I'm just going to write 5 on the top. 5 secant square of 5x. Now, is there anything you can do from here? Not much, really, because the tangent of 5x is under the radical, so you can't really simplify. And so, therefore, this is as far as you can go. So, this is the final answer of, so that's the derivative of square root tangent of 5x. And this concludes our video for the day.